Let me find out if I can work this thing. Very good. uh, my name is Muench, as Mike mentioned. I'm in the industry for over 25 years. Started my career at Siemens. One of my old managers over there, Raj Batra. I worked here in the US. I've been part of the WinCC architecture team back in Germany, designed the HMIs for Siemens at the time, and left Siemens in the mid-2000s to go to Microsoft to work in the embedded team there. And after a short while there, I realized there's this new big thing coming called the Internet of Things. At the time, it was called differently. It was called System of Devices, System of Services. A lot of different names floated around, and nobody really knew what it is. Very similar to that thing that's called cloud, that also kind of was in a beginning very hard to understand. So I want to take a little bit different approach before I get into the PROFINET part, is to explain to you what actually the Internet of Things is. We hear a lot about it, but we haven't really figured out what exactly is the term Internet of Things meaning. A thing is a device, but it can also be a virtual thing. It can be a timer, it can be an alarm, or it can be a physical device that has a representation in the digital world. In the Internet of Things means we want to connect those devices directly to each other, not necessarily over the internet, and that's where the confusion comes. You don't have to have devices connected to the internet in order to have an Internet of Things. You connect devices to each other. And this is kind of, in the PROFINET world, kind of a very old term, right? You connect devices to each other, you bring value to the devices individually, and have a compound network of devices. That is already part of the Internet of Things. We're now extending these devices through the internet to other devices that haven't been talking to these devices before. And some very important part of that is security, which I will come in a little bit to. It is considered the next big megatrend in technology, I would say in IT technology, but it also spans across multiple industries, including Medicare. I'm very happy about the speech of the colleague from GE, who's summarizing these trends very nicely up, that it's not just industrial, it's not just home, it's not just medical, but it spans everywhere. And you want to connect all these devices together. Intel, and they constantly revive their numbers. I think they're currently at 50 billion or something like that. So every time I see a new study from them, the number explodes on the device side. But estimates even by next year, we have already 3.8 billion devices talking to each other, from which we will not see that many, because we have them invisibly in our plants, we have them invisibly in our homes, and they're just talking to each other, making our lives more pleasurable, or the factory more productive. But the Internet of Things also brings a lot of challenges with it that need to be addressed from the get-go, from the beginning. And most of that is around security. If you heard about Stuxnet, I'm a WinCC architect. It hits me pretty hard that exactly in WinCC this Stuxnet showed up. But at the time when WinCC was conceived in the 90s, nothing was connected. There was not really an intrusion possibility. That came over time, and security was at the time then an afterthought. With the Internet of Things, we have to bake security in from the get-go, put it into the technology right away, and make sure that the solutions that we're offering are secure all the way from the sensor level up to the device level, which is then maybe mobile and connected to the internet. So I'm saying here, we have to make sure that the devices are connected from the sensor level to the control level, to the enterprise level, to the cloud level, and then to the mobile level. These are 4 different networks we're spanning with 4 different network topologies, 4 different security requirements, and 4 different performance and liability considerations. The data needs to be transparent. We want to have a mobile phone talk to a sensor without converting the data 5, 6, 7 times. This takes away from the speed of connectivity, and will make it much harder for an ecosystem to survive and integrate multiple devices to each other. PROFINET is a very interesting protocol because it's very established on the manufacturing floor. It has all the reliability concerns that we need in the factory floor, but it wasn't really designed around security. Security, again, was an afterthought in the PROFINET realm, and so it is kind of isolated on the manufacturing layer, possibly with a DMZ connected to an IT layer, but that's where currently PROFINET is ending. You see a lot of communication inside a robot, for example, between the sensors, and we saw tons of nice graphics how PROFINET was connected, so I don't have to show you that again. But if a mobile phone or a BYOD device, how it's called these days, bring your own device, wants to connect to the robot in order to read diagnostic data, and I'm talking really about non-real-time data. The Internet of Things at this stage has a protocol called PROFINET on the real-time side, and then wants to be extended out to devices like mobile phones through the Internet of Things. A mobile phone that wants directly to connect to the robot it requires an inbound port on a robot. That's kind of a bad thing to do in the IT world, because you have to open up a vulnerability that you don't want to have. So this is not a good idea. You should go through an infrastructure component that sits in the middle and that we all have, called PLC or a pack or a controller, or a dedicated box that establishes secure communication between the robot and the controller, and the mobile phone then connects to that controller. So we have an abstraction layer in the middle, and since these are all devices, they're all things talking to each other. We're talking already in this stage from the mini Internet of Things. What if the mobile phone is on the internet? I have a remote maintenance worker that wants to access the maintenance data and the security data from the robot. It should not directly connect to that controller again. We do not want to put the PLCs in the pack controller with an open port directly on the internet. That's another security problem that intruders can utilize and hack into your stationary devices. So that is not a good idea. Now this is where something comes into play that I mentioned earlier, this nebulous thing in the sky called cloud, which is a outsourced computing power, I would say. I connect my mobile phone and my controller to the cloud, and with that I can create a secure communication. The controller in the middle is talking outbound to the cloud. There's no inbound port necessary. And the mobile phone can only talk outbound. It has no inbound ports anyway. Talks also outbound to the cloud. And the cloud works kind of as a smart relay, as one of those very cheap Netgear boxes that you have in your office. It's just a bit smarter because it's running elastic in an outsourced computer data center. That's how we see the Internet of Things grow into realms that where Profibus was not necessarily originally conceived for, but we can extend PROFINET over a system like that into the Internet of Things, and specifically to remote maintenance workers that want to have real-time access to the database, to the devices themselves. And if I talk about real-time in this sense, it's quasi-real-time. It's called the Internet real-time. It's not at millisecond layer. It's about in a second space. It's still better to have a second space real-time than getting a paper printout per fax or something like that. So what we do is, and that's something we're doing in our company, we're basically transforming PROFINET tags and groups of the PROFINET into virtual things. We combine them as data and UI. You heard before I was one of the architects of WinCC, so we're working on the next generation of HMIs, which we call NMeyes. NMeyes stands for Natural Machine Interface, and is a combination of what's traditionally an HMI and the NUI generation that's out there, natural user interfaces, and bringing that together in a new design for the UX, which is standing for user experience. The idea here is that all the HMI is running in HTML5, runs on any browser that you have, on any device that you have. You can run it on any device inside the factory or outside the factory. We have always the same look and feel. You have always the same operation with the device, and you can learn very quickly the operation of those devices. Since those things deliver their UX themselves, the thing knows exactly what it wants to represent. The UI is also forming automatically. You add a new machine, a new UI shows up. You add a new machine to a line, inside the line, a new UX shows up on the screen. So less engineering effort to build those screens for HMIs than in the past, and a much faster communication with the people that are connected through the Internet of Things to your devices. As mentioned before, we transport then these things across multiple networks to the mobile devices. We have the factory automation network, the IT network, the cloud, and the mobile network. All these four require a different set of security credentials. We still make sure that the telegram that was originally a PROFINET tag or telegram is sent secure through these four layers to its target device. If you're directly connected in the factory floor, there's only one network to consider. But if you go through the IT and you want to sit in your office space and look at your data, you have different requirements that the IT is setting. We do not want to bypass the security that the IT guys set up. We want to work with them. We want to use their policies and use their security credentials that they have set up for their network. And then, as I said before, we want to display the UI on any modern browser or device that's currently on the market. If you have an Android, an iOS device, a Windows device, doesn't matter. They all display HTML5. The standardization of HTML5 is actually very, very good these days from a display perspective. From an interoperability perspective, there's still some quirks here and there, but it's getting to a point where we have one browser and one UI, and you can run that on any device that you have. And then once the UI is on the screen, the PROFINET tags will be updated on the fly on the screen, so you have live moving HMI or NMeyes screens no matter what device you're on. As a customer benefits, we saw that in the GE slides already. Remote maintenance workers are getting the information about status in the factory before they actually arrive at the factory. They can bring the right parts from the warehouse, don't have to go to the factory, do an analysis, go back to the warehouse, pick up the part, and go back to the factory. That's a lot of time wasted for a critical emergency situation and reduces the downtime if you have this factory worker updated with the latest information before he comes to the factory. And preventive maintenance, also I saw that in earlier slides, means that I know when a part will break, and I schedule a downtime way before this happens. And you do remote analysis with these kind of things. You can have these KPIs transmitted to remote workers that have maybe their own analysis of the KPIs that are much better than a live analysis system these days. There are a lot of workers out there that have years and years of experience how to look at graphs and tell you when exactly something breaks. And to give these workers access to the data is super valuable. And then building business intelligence systems out of that is the challenge that we have in the next couple of years to bring this data to some real fruition. And prevention of downtime, I think, is kind of the holy grail of manufacturing. In the Profi Energy space, we can also do a lot. Profi Energy is a new system that I have been introduced a couple of years ago to shut down unneeded controller, unneeded IOs. And with monitoring these Profi Energy scenarios, we can also build new decision systems that decide when a machine or a robot or something has to be shut down or can be shut down in order to save energy. You can have smarter startup ramps on your factory floor. And of course, monitoring the energy is kind of the first step of everything. You want to know what kind of energy you're using, which device is using what energy, and then making smart decisions how to optimize your plant and production lines. With profiles and reading about the history of your energy profiles, you can make smart decisions in the long term for the planning phases for your next segments of your factories in order to optimize down the road for the upcoming parts of your manufacturing lines. We, together with Phoenix Quantum, have built a product called Factory Relay that we actually just shipped in Chicago. I just flew here from the Connected World Conference in Chicago to this event, and we built this Factory Relay based on the Internet of Things experience that we collected over the last 5 years. Some of my old colleagues from Minnesota actually joined my company to drive this product forward. It is completely based on HTML5. All the UI and NMI parts are HTML5 based. We're looking at small devices, from small devices up to 4K screens, which will also enter the manufacturing space as large screen monitors with very fine details. We do cross-network support for all these 4 layers that I mentioned before, and we're running on hardware from Phoenix Contact on their box PCs in order to achieve the best hardware and industrial-grade performance that we can get out of a solution like that. The whole purpose of the factory relay is to give access to remote workers to any data that's out there. We will have transformers from PROFINET to things. We have transformers from OPC UA to things, virtual things, as I mentioned before, and transmit them as combined user interface and data to a mobile device or another device that wants to consume it and start interesting rules with it. So the factory relay includes a rules engine that allows you to work with energy data, work with TAC data, and it's a kind of a mini BI system that allows you to create new paradigms for your factory automation systems. I think that's kind of my story for today. So I thank you very much for coming. I hope I got a little bit of the time left that we lost over the time. And thank you all for this opportunity.